Dear children, in the previous session, we discussed how to find the formulae for integration of some particular functions. Now, in this session, we will be applying those results which we have discussed earlier. Let us see how knowing those results is going to make integration more convenient and more easy for us. Now, taking the first one, you can see it is of the form 1 divided by square root of sum of two perfect squares. Only thing is coefficient of x square is 4. Let us first convert it into 1. For that, what we are going to do, we will take 4 common from the denominator. So we are taking 4 common from the two terms which are written under the square root in the denominator. So if I take 4 common out of these two, 1 reduces to 1 by 4 and this gets added to square of x. Now because 4 is a perfect square, we can simplify it and we can write the expression as 1 over 2 integral of 1 divided by square root of square of 1 by 2 plus square of x. Now look at this. The denominator is again under the square root and it is sum of two perfect squares. So it is of the form 1 over square root of a square plus x square. So recall the integral for this. According to the formula, it should be 1 by 2 log x plus square root of x square plus a square. Whether you write a square plus x square or you write x square plus a square, it has the same meaning. So we can write it as 1 over 4 plus square of x and a constant of integration. Let us suppose the constant of integration is C1. Now when we simplify the term under the square root, we take LCM, it reduces to, look at the later part, it will become 1 plus 4x square divided by 4 and the entire term under the square root. So because 4 is a perfect square, we can write it as square root of 1 plus 4x square divided by 2 and x over here plus constant of integration. If further LCM be taken, we can even write it as 1 by 2 log modulus of 2x plus square root of 1 plus 4x square and this entire term divided by 2 plus constant of integration. Now if you look at this part, it is of the form log m over n. So we can write it as log m minus log n and both getting multiplied by 1 by 2. So separating these, we get half log modulus of 2x plus square root of 1 plus 4x square then minus half log 2 and the constant of integration. Now if you look at the last two terms, half of log 2 is a constant and C1 is also a constant. So they both undergoing whatever operation is written here will result into a new constant. So we can write our integral as 1 by 2 log, solution of the given integral can be now written as half log modulus of twice of x square root of 1 plus 4x square and a constant of integration. Let's see with the constant which is obtained after subtracting 1 by 2 log 2 from C1. Now moving on to the next one. This is not in the required form. So we'll convert it into the desired form and then we are going to apply the one of the results. You can see x to the power 6 can be written as square of x cube and we can go for using substitution here. If we put x cube as t, then you will find the derivative of x cube is 3x square dx, which comes out to be dt. Or we can write x square dx as 1/3 of dt. Now do this substitution. On putting the value in the integral, we get I as 1/3 of integral of 1 over 1 minus t square dt. So x square dx is replaced by 1/3 of dt. Okay. And in the denominator we get 1 minus t square. T is cube of x. Now integrated, it is of the form, which form of integral? Integral of 1 over difference of two perfect square. So this can be taken as a square minus x square. So again recall the result and see what is the integral of that. Over here a is equal to 1. So it is 1 over twice of a. Then it is log a plus x we write. In place of x here it is t. So 1 plus t over 1 minus t and the constant of integration. Simplify and substitute the value of t. So it is 1 over 6 log 1 plus t is how much? It is cube of x. So x cube over 1 minus x cube plus constant of integration. So this is the required result. Now moving on to the next one. Look at these two. So we are going to integrate 1 over square root of x square plus 2x plus 2. Fine. Now this has to be, if you see the denominator, it is not represented as a sum or a difference of two perfect square. So there is a need of converting it into two perfect squares so that one of the results can be applied. So we will simplify it. X square plus 2x plus 2. You can see we can write it as x square plus 2x, and this 2 can be written as 1 plus 1. So if we look at the terms which are within the bracket, they get converted into a perfect square, which is square of x plus 1, and this leftover 1 can be written as square of 1. So our integral is now 1 over square root of x plus 1 whole square plus square of 1 dx. So which form of integral it has taken? It is of the form integral of 1 over square root of x square plus a square. In place of x, what do we have here? X plus 1. So we can simply use the formula, and wherever it is x mentioned, you can replace it by x plus 1. So it will be log modulus of x plus 1 plus square root of square of the term which is in place of x. So it will be x plus 1 whole square plus square of 1. So log x plus square root of x square plus a square. What do we have in place of x here? It is x plus 1 and the constant of integration. You will see whenever you will be simplifying this part, you will expand it, it will result into the given quadratic polynomial only. So we can write it as log modulus of x plus 1 plus square root of x square plus 2x plus 2 and the constant of integration. Now let us check the next one. If you look at the next one, it is again a quadratic polynomial but not converted into two perfect square. So we'll convert it into two perfect square, but before doing that, we will reduce the coefficient of x square into 1. So let us simplify it. We have 9x square plus 6x plus 5. So we are going to take 9 common from each term. We are left with x square plus 6 over 9 into x. So 6 over 9 will be 2 by 3 times x, and then plus 5 over 9. So this is the quadratic polynomial you will convert into two perfect squares. So let us see adding what and subtracting what is going to help us. Let us see what should be added here now. You will check the coefficient of x. Coefficient of x is 2 by 3. So divided by 2. When this is divided by 2, we get 1 by 3. Now square of this term will be added and subtracted. So what did we check? We checked the coefficient of x. We divided it by 2 and so what is left? So 1 by 3 is left. So this term which is left, its square is to be added and its square is to be subtracted. So what are we adding now? We are adding square of 3. So because square of 3 is added in the expression, we will be subtracting square of 3. So already 5 over 9 is here. We are going to subtract square of 1 over 3 which is being added. Now let us simplify these. Take the first 3 terms together. You will see they are getting converted into the form a square plus b square. This will be plus twice of ab. So x is a and 1 by 3 is b. So a square plus b square plus twice of ab. We can write it as a plus b whole square. In the later part, let us simplify this as well. So we have 5 over 9 and this on taking square will become 1 over 9. Both will get subtracted. So what are we left with? 5 minus 1 whole divided by 9. So 5 minus 1 is 4. So the result comes out to be 4 over 9. Now 4 is also a perfect square, 9 is also a perfect square. So 4 over 9 can be written as 2 over 3 whole square. Now let us place it in the integral. See what our integral is now. It is integral of 1 over 9 we will have outside, which we can write here also, multiplied with x plus 1 by 3 whole square plus, so 9 is multiplying with the sum of these two, dx. Now look at this expression. It is of the form 1 over x square plus a square. So check for the result for integral of 1 over x square plus a square dx. You will find in place of x here we have x plus 1 over 3. See, we are able to replace x with x plus 1 over 3. The reason being we reduced the coefficient of x square into 1. Okay, so if you are doing that initially in the formula, you can quickly replace your x with this term. So 1 over 9 is already there. According to the formula, it will be 1 over a. A is 2 by 3. Then tan inverse x over a. So in place of x we have x plus 1 over 3. And in place of a we have 2 over 3. So we need to just simplify it. You can see with 3, 9 gets cancelled out and we are left with 1 over 6 here. And then tan inverse, we will take LCM in the numerator. It will become 2x plus 1 over 3. And this 3 will get cancelled out with the 3 in the denominator of the denominator. So on simplifying this, we get 3x plus 1 divided by 2 here and constant of integration. So you can see how the given polynomial can be converted into either sum or difference of two perfect square. So taking another one, in all these questions we have done till now, you will see in the previous two also and this one also. The numerator is a constant. Okay, so it is of the same nature. Let us convert the term under the square root into two perfect squares. So we'll simplify it quickly. We have 7 minus 6x minus x square. So first I convert the coefficient of x square to be to plus 1. So we take minus common. So it is x square now plus 6x minus 7. Now you convert it into two perfect squares. So let us see what should be added or subtracted simultaneously. So coefficient of x here is 6. If we divide it by 2, it comes out to be 3. So square of 3 you will add and square of 3 you will subtract. So we are adding square of 3 and we are subtracting square of 3. Now let us simplify this. Look at these first three terms. They are reducing into a perfect square. So assume x to be a and 3 to be b. So this is a square plus b square and this will be twice of ab if you check it. So it is actually expanded form of x plus 3 whole square. So the first three terms are resulting into x plus 3 whole square. Checking the next one, square of 3 will be 9. So minus 7 and minus 9 is minus 16. So it will be minus 16. 16 can be written as square of 4. Now multiplying this minus inside, this term becomes positive. We get square of 4 minus square of x plus 3. So this is actually 7 minus 6x minus x square. So written in a different form. So write this in the denominator under the square root in the given integral. So we have integral of 1 divided by square root of difference of these two perfect square. So square of 4 minus square of x plus 3 dx. Again check the results. You will see it is of the form integral of 1 over square root of a square minus x square. So if you check the result, you will see its integral is sine inverse x over a. So what do we have in place of x here? It is x plus 3, and in place of a we have got 4. So the integral is sine inverse of x plus 3 divided by 4 plus constant of integration. Now see the next one. This one is different from what we have done till now. You will find here in the numerator we don't have a constant. Numerator is not a constant, you can see. So let us see, is there any relation between the quadratic polynomial in the denominator and the numerator? You will quickly find if we put 2x square plus x minus 3 as t, then on differentiating it, the derivative comes out to be 4x plus 1 dx is equal to dt. So what has happened? The entire numerator along with dx has come out to be the derivative of this quadratic polynomial. But every time this will not happen. The numerator may be derivative of this, it may not be. So for this one, 4x plus 1 into dx has come out to be the derivative of 2x square plus x minus 3. So let us do the substitution and integrate. So we are having 1 over square root of t dt. Now 1 over square root of t means you are integrating t with exponent minus 1 by 2. So integrate it. The integral of this will be t with exponent minus 1 by 2 plus 1 divided by minus 1 by 2 plus 1 and the constant of integration. See the denominator, it is 1 minus 1 by 2. So in the denominator you will get 1 by 2. On converting it into multiplication we get 2 here. And this is t to the power 1 by 2. That means square root of t plus constant of integration. So putting the value of t we get 2x square plus x minus 3 under the square root. So the integral is 2 multiplied with square root of 2x square plus x minus 3 and the constant of integration. So in this case we could see 4x plus 1 came out to be the derivative of the polynomial in the denominator under the square root. Let us see if it does not happens. So we'll explore the next such question. Over here you will find 5x minus 2 is not the derivative of 3x square plus 2x plus 1. So we'll try to convert it to that. Now how that can be done? Let us put 5x minus 2 as a times derivative of 3x square plus 2x plus 1 plus b. So what we are trying to do, we are trying to write 5x minus 2 in some new method so that it can be represented as the derivative of this quadratic polynomial. So we have to find those a and b for which both the sides can become equal. So let us simplify it. 5x minus 2 will be a times derivative of this. What is the derivative of this? It will be 6x plus 2 and then b. Now let us evaluate for a and b. First we will equating coefficient of x and constants respectively on both sides. Constants respectively. So on both the sides we will compare the coefficients of x and the constants. So let us first compare the coefficient of x. On the right side you will see coefficient of x will be 6a. On the left hand side it is 5. That means a can be written as 5 by 6. Now compare the constants. On the right hand side constant is twice of a plus b. So twice of a plus b is equal to the constant on the left hand side, which is minus 2. Because we already know what a is, so we can shift it to the right side. and solve for b. So minus 2 minus twice of a, and what is a? It is 5 by 6. So cancelling out 6 with 2 and then further taking LCM. So 3 into minus 2 is minus 6. So minus 6 and minus 5. 11 over 3 it is. So what are we going to now write? We will write 5x minus 2 as a times, which means 5 by 6 times 6x plus 2 and then plus b. What is b? Minus 11 over 3. So this is 5 here. Okay, I'll rewrite this. So the numerator a is 5 over 6 here. Okay, so this is the new way of writing 5x minus 2. If you will expand it and solve, it will come out to be this only. So you can see in the question 5x minus 2 is getting divided by this. So we will break it into two integral. This whole divided by the quadratic polynomial separately and this divided by the quadratic polynomial separately. So we are breaking our integral into two integrals. First one will be 5 over 6 integral of 6x plus 2 divided by 3x square plus 2x plus 1. So this is our first integral. Next will be integral of minus 11 by 3 divided by this. So minus 11 over 3 I will write outside, and within the integral we can write 1 over 3x square and then plus 2x plus 1 and dx. Okay, now see. Second integral is of the type where the numerator has become constant. So this I will convert into 2 perfect square. But if you look at the first integral, you will see here substitution is possible. Okay. So in first integral, what we are going to do? In the first integral, we will put 3x square plus 2x plus 1 is equal to t. So this will imply 6x plus 2 dx is equal to dt. In second integral also we will do some work. See, in second integral, look at the denominator. Let us convert it into 2 perfect square. So you can see coefficient of x square is not 1. So we have to make it 1. So what we will do, we will take 3 common and the polynomial becomes x square plus 2 by 3x and then plus 1 by 3. Now convert this into 2 perfect square. So 3 times it will be x square plus 2 by 3x. Let us see what is to be added and subtracted. Coefficient of x is 2 by 3. If we divide it by 2, 2 will get cancelled out. We get 1 by 3. And what is square of 1 by 3? It is 1 by 9. So we are adding 1 by 9 and we are going to subtract 1 by 9. Let us compile it into 2 perfect squares. This is square of x plus 1 by 3. And if I take LCM here, I will get 3 minus 1, which is 2 divided by 9. So 2 divided by 9. Can we write them as perfect square? 2 can be written as square root of 2. 9 can be written as square of 3. So 2 by 9 can be written like this. So you can see in the second integral, you have converted the denominator into the sum of 2 perfect square. So in the first integral, do this substitution. In the second integral, convert the denominator into this form. So what is I now? It is 5 over 6, then integral of 1 over t dt. In the later part, 11 over 3 we were already having, and this 3 will also multiply. So 3 into 3, 9. And it is integral of 1 over x plus 1 by 3 whole square, then plus root 2 over 3 whole square dx. Now we are ready to integrate both. Integral of 1 over t is log t. So it will be 5 over 6 log t. Later part is in the form 1 over x square plus a square. So according to the formula, its integral is 1 over a. What is a here? Root 2 over 3. And then tan inverse x over a. So x plus 1 over 3 will get divided by root 2 by 3. So x plus 1 over 3 divided by root 2 over 3 plus constant of integration. Now we need to only simplify it. Put the value of t here. T is 3x square plus 2x plus 1. Over here 9 gets cancelled out with 3. So I get 3 here. So this is now 11 over 3 root 2. And what do we get with tan inverse? Take LCM here also. We get 3x plus 1 divided by root 2 plus constant of integration. So this is our integral. Okay, so we convert the numerator into the form where one part we are able to use substitution, on the other part we are able to convert it into 2 perfect square and hence integrate. Let us check another one of the same kind. Over here I'll try to convert the numerator directly in the form which can be derivative of x square plus 2x plus 3. Let us see how that can be done. You can see if this be differentiated, okay, derivative of x square will come 2x, but we don't have 2x here. So let us try to get 2x. In order to get 2x, we can multiply it with 2 and we can divide it by 2. So numerator is multiplied with 2 and it is divided by 2. X square plus 2x plus 3 under the square root as it is. Now check again. If this be replaced by t, its derivative will be 2x plus 2. So we don't want this 4 here. So we are going to break 4 into 2 parts. We will write this as 2x plus 2 and then plus 2. This divided by square root of x square plus 2x plus 3 dx. Now let us break it into two integrals. So 1 by 2, first integral will have 2x plus 2 over square root of x square plus 2x plus 3. This we have in the first integral. And what about the second integral? In the second integral, we will get half integral of 2 over square root of x square plus 2x plus 3 dx. So here 2 and 2 gets cancelled out. So what do you see? It is broken into two integrals now. Where in the first part we are able to use substitution. In the second part I will convert it into 2 perfect square. So we'll write in first integral, put x square plus 2x plus 3 is equal to t. That means its derivative, which is 2x plus 2 into dx, can be replaced by dt. So we'll write our integral. This substitution we are doing only in the first part. So 1 by 2 and then this term under the square root is replaced by t and this entire numerator is converting into dt. So we get 1 over square root of t dt. Let us see what to do in the later part. In the later part, we'll try to convert it into 2 perfect square. See, here it is quickly possible. We can write it as x square plus 2x and 3 can be written as 1 plus 2. So 1 I will keep here and then plus 2. Okay. In the meanwhile, we can write this integral as integral of t to the power minus 1 by 2. Okay. And look at the second part. It is now 1 over square root of square of x plus 1 and then I am left with 2. So 2 can be written as square root of 2. Now as you can see, this is also converted into square root of sum of two perfect squares. So it is also in the required form. We can integrate both. So integral of t to the power minus 1 by 2. That comes out to be t to the power 1 by 2 divided by 1 by 2. So over here you can see 2 and 2 gets cancelled out. And this is of the form integral of 1 over square root of x square plus a square. So we will be able to write it as log modulus of x plus 1 plus square root of sum of square of these two terms. So if this be expanded, you see it will come out to be x square plus 2x plus 3 only, and the constant of integration. Now putting the value of t here, which is because it is t with exponent 1 by 2, we can write it as square root of t, and t is, you can see the substitution, it is x square plus 2x plus 3. So t is substituted, and the later part is log modulus of x plus 1 plus square root of x square plus 2x plus 3, and the constant of integration. Taking one more of this kind, see here, it is difficult to convert 5x plus 3 into the derivative of this, but it can be done, but it will take time. So what we can do, we can put 5x plus 3 as a times. Now I'll write the derivative directly. We write a times derivative of this polynomial. So what is the derivative? It is 2x plus 4 plus b. Now what? Equating coefficient of x. This means because they both are equal, so like terms on both the sides will be equal. So this will imply 2a is equal to 5, which means a should be 5 by 2. And what else? Equate the constants. We will have 4a plus b is equal to 3, which will imply b is equal to 3 minus 4 times a, and a is 5 by 2. So with 2, 4 gets cancelled out. So this is 3 minus 10, which is minus 7. So b is coming out to be minus 7. A came out to be 5 by 2. So what can we write 5x plus 3 as? It will be a, which is 5 by 2 multiplied with 2x plus 4, and then plus b. B is minus 7. So this is what we get. So in the given integral, we will replace 5x plus 3 by this, and we will take the denominator separately with both these terms and convert the integral into two parts. So let us see what they are. Sorry. It is now 2x plus 4 divided by square root of x square plus 4x plus 10 dx. This is our first integral, minus 7 times integral of 1 over square root of x square plus 4x plus 10 times dx. In the first part, we will use substitution. In the second part, we'll convert it into two perfect squares, and we will use the formula. Why we are converting it into two perfect square? Because we have reduced the exponent into a constant. So it is one of those forms where the formula can be directly used. So we'll write in first integral, because we are doing substitution only in the first integral. So in first integral, put x square plus 4x plus 10 is equal to t. So its derivative of x square 2x plus 4, that of 4x, dx is equal to dt. So rewriting the integral, it is 5 by 2 times integral of 1 over square root of t dt. In the later part, let us try to break it into two perfect squares. See, we will be able to do it directly. X square plus 4x I will write together. 10 I will break as 4 plus 6. And you will find the numbers, the expression written within the bracket is actually a perfect square. Now this is 5 by 2 integral of t to the power minus 1 by 2 minus 7 integral of 1 over square root of, this is x plus 2 whole square, and 6 can be written as square root of 6 whole square dx. See, if you look at the previous method which we were doing to make it a perfect square, you will see we have exactly done the same thing but directly. Look at this, the coefficient of x is 4. If we divide it by 2, we get 2. So square of 2 is to be added and it is to be subtracted. So in this, you will add 4, you will subtract 4. Okay, so when you add 4, you get the 4 here. And when you subtract 4, 10 minus 4 comes out to be 6 only. So this is what you are going to get. Now we are ready to integrate it. Now integral of t to the power minus 1 by 2 is t to the power 1 by 2. That means it is square root of t, and what else? Are we going to get something else? It will be t to the power 1 by 2, and this will even get divided by, because its power will be 1 by 2, it will get divided by 1 by 2. Then minus, it comes out to be, if we move on to the next part, it is minus 7, then integral of 1 over square root of this is x square plus a square. So recall the formula for 1 over square root of x square plus a square, and then you go for integrating it. See what you get. It will be log x plus 2 and then square of this plus square of root 6. So if we simplify it, it will be x square plus 4x. Okay, let us rewrite this so that it can be accommodated properly. It is minus 7 log of modulus x plus 2 plus square root of x square plus 4x plus 10. Modulus close plus constant of integration. You can see 2 here gets cancelled out. We get 5 root 2. Root t, sorry. T we can replace with its value. So 5 into square root of x square plus 4x plus 10 minus 7 times log modulus of x plus 2 plus square root of x square plus 4x plus 10 and the constant of integration.